Hello, please join me in this video so we can learn a variety of ways to represent organic molecules. So given the chemical formula C3H7Cl, we can represent this compound in a variety of ways. One of them is to write it as CH3, CH2, CH2Cl, and we call this the condensed format. Another option is to write it as CH3 connected to CH2 connected to CH2 and then Cl, which is a partially condensed format. Another option is to use the Lewis structure format, so that is carbon connections and then the chlorine, hydrogen, 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 and then we need to show the lone pairs on chlorine. The fifth and the most favorite method is where we don't have to show the carbon and the hydrogen atoms. So we call this a bond line structure. In a bond line structure, we use zigzag lines or kind of a connection. We just draw lines with connections, and at each connection there is a carbon atom. So this, we could say this is C1, C2, C3. So that's carbon number 1, number 2, number 3. At each connection there is a carbon atom. So we call that the bond line structure. It kind of helps to have neat structures. So from now onwards, we are going to try to be able to use bond line structures. But you need to be able to interconvert any of them to the other one if you're asked to do so. For example, let us draw the partial condensed format for, let's say, this compound connected to a carbon which is sp3 hybridized. So the reason I'm giving this example is because students usually make mistakes. So they're just going to count like 1, 2, 3, 4, 5, and then they'll draw the lines 2, 3, 4, 5, and then they'll put a triple bond there. This is incorrect. Whenever you have a triple bond, we need to make sure that we take care of the geometry of the molecule. sp hybridized orbitals usually are linear. So the best way when you have such kind of structure is to start with a triple bond, and then we can draw the carbon number 5, which is going to project out of the triple bond. And then we have another one which also has to be linear, and then we have the last one here. So this is carbon number 1, number 2, carbon number 3, carbon number 4, and number 5. So this one is correct because we are showing the correct geometry of the molecule. Next, let us look at what is called the functional groups. That is a group of atoms that have similar characteristics in terms of reactions and the chemical structure. So the first group, we're going to call them alkanes. Alkanes is where we have carbon and hydrogen atoms only. So carbon and hydrogen atoms. So in this case, we have 1, 2, 3, 4, which means we could write this as CH3 connected to CH2, connected to CH2, connected to CH3. So we call those ones alkanes. We could have an alkane attached to another compound, so like this one here. If it's attached to a halogen, we call this an alkyl halide. So the alkyl group is the one that comes from the alkane. So we call that an alkyl halide. So anytime whenever you see R, it's going to represent an alkane, a portion of the alkane. If it is a branch, we call it alkyl. It's a kind of a branch of an alkane attached to something else. So we're going to have alkyl halides. We're going to have alkenes where we might have a double bond. We're going to have alkynes, that is the ones involving triple bonds. We're going to have alcohols with an OH, ethers where the oxygen is between two alkyl groups, thiols, sulfides, aromatic groups, for example, the benzene. Ketone. In a ketone, what happens is we have a carbonyl, carbon bonded to an oxygen. So such kind of groups, we call them ketones. We could also have an aldehyde. So instead of having two carbon atoms flanking a carbonyl, in one side we have a hydrogen. So whenever we have one side being a hydrogen, we call that an aldehyde. If we have an OH instead of a carbon on one side, we call that a carboxylic acid. So carbonyl with an OH on one side, we call it a carboxylic acid. If we replace that one of the carbons with a halogen, we call it an acyl halide. For an hydride, what happens is we replace the carbon of the ketone. We replace it with another portion of the carbonyl, which is connected to an oxygen. So anhydrides refer to an oxygen that is flanked by two carbonyls. And then we also have an OR replacing the carbon of the ketone, so we're going to call that an ester. So remember, all these are related to the carbonyl. We are only changing this other functional group, the one connected to the carbonyl. If we connect an amine, nitrogen connected to an alkane or an alkyl group in this case, then now it becomes an amide or an amide. If we have just a nitrogen connected to alkyl groups, we call that amine. So what I'm saying is that you need to be able to recognize the functional group when you see it. And this you can only achieve by practice. So make sure you look at some of the examples and practice accordingly. I actually do have one practice problem here that we could do. So can you identify some of the functional groups that you can see in this compound? Well, I can see an OH connected to a carbon. So this is going to be an alcohol. I can see a triple bond connected to a carbon, so I will call that an alkyne. I can see a double bond, and I will call that alkene. I can also see an alkane, just carbon-carbon bonds, no triple bonds, no double bonds, no oxygen anywhere. So this is going to be alkane. And then we have an amine, nitrogen connected to alkyl groups, we call that amine. And then we have the benzene, which is an aromatic compound. So we can say that is going to be benzene, or we can say it has an aromatic compound attached. Let us see how many functional groups we identified. 1, 2, 3, 4, 5, 6. Of course, there's another alcohol over there. Anything else we left out? I don't see any, so I guess we got it. All right. So have a good one and enjoy.